When talking about the unit circle, the first thing you really have to talk about is special triangles. We have two special triangles. The first one is the isosceles special triangle, and it has two base angles of 45 degrees with a right angle. And if we call these sides 1, then if we use Pythagorean theorem, 1 squared plus 1 squared equals the hypotenuse squared tells me that the hypotenuse is radical 2. And the other special triangle is the equilateral triangle, which has all angles 60 degrees. But with the equilateral triangle, just like an isosceles triangle, if you drop down a altitude, it splits it in half, so these are equal. And it splits the angle in half, so this becomes 30 degrees. Now I have my second special triangle, 30, 60, 90. So if I say that this side is 2, then this side would be 1 because it's half of it. And if I want to find the last side, again, I'll use Pythagorean theorem. Now I have the hypotenuse squared equals the side squared plus the one I don't know. And that tells me that b squared is 3, so this length is radical 3. Using that information, I can find, I'll just give the 3 trig functions, and that is, in addition, we can find the other 3 as well. What I wanted to remind you is 45 degrees is equivalent to pi over 4. So I could say that the sine of pi over 4 is opposite over hypotenuse, which if I rationalize the denominator is radical 2 over 2. Cosine of pi over 4, and I'm picking this angle here, is adjacent over hypotenuse, which also is radical 2 over 2. And my tangent of pi over 4 is opposite over adjacent, or 1. Now if I use this angle, 60 degrees, that's the same as pi over 3. And then I know that sine of pi over 3 is opposite over hypotenuse. Cosine of pi over 3 is adjacent over hypotenuse, and tangent of pi over 3 is opposite over adjacent. And pi over 3 and pi over 6 are complementary, which means that the cosine of pi over 6 equals the sine of pi over 3. The sine of pi over 6 equals the cosine of pi over 3. And then we know that the tangent of pi over 6, we can just say this is pi over 6 over here, is 1 over radical 3, or if I rationalize this, radical 3 over 3. Now if we think about our unit circle, we can split it. So if I split into, let's say this part, this is pi over 2 here, I have 0. If I split just half, because half is pi, into 6 pieces here, 1/6 of pi is pi over 6. And then twice pi over 6 is pi over 3. If I was to divide it in quarters, I'd have pi over 4. So I have all my angles that I'm talking about here. And I'm going to show you a little hand trick to help you remember it. And that's what we'll talk about in with the trig functions, because we're only looking at acute angles now, so only in this first quadrant. So think about this little trick. Think about a hand. If you hold your hand out, and I'm going to label it just like I labeled that circle there. So this is 0, and this is pi over 2. I'm going to label my other fingers pi over 6, pi over 4, and pi over 3. Now, the cool thing is if I pick one of my fingers and I bend it, so let's say I'm bending that one, it becomes your comma. And then for pi over 4, the top fingers are your cosine of your angle, and the bottom fingers are your sine of your angle. And so it's the number of fingers under a radical divided by 2. So cosine of pi over 4 is radical 2 over 2. Sine of pi over 4 is radical 2 over 2. If I picked another finger like pi over 3, cosine of pi over 3 is 1/2. And sine of pi over 3 is radical 3 over 2. So it's a cool little trick to remember your trig functions.